All right, so yesterday was the test. These are the test grades. Any questions? Yeah?
When we can take something and there's like an answer less than decimal, is there a certain amount that we have to leave?
It'll tell you in the problem.
Well, I mean, like, but when you're still doing it, when you're still like.
Oh, like in the middle of the problem?
Yeah.
Yeah, just.
I messed up on that. I only used 3 and it gave my answer wrong.
Oh, okay. Yeah, I would just leave it as accurate as you can, like leave the result in your calculator, and then just use that result unrounded, like to do the next step. And if you can't figure out how to do that, I can help you, or just write it to like 10 spots, you know what I mean? Like 10 decimal places, and then it's a little of a hassle that way. It's better if you can like save it in your calculator somehow, so you don't have to retype it, but yeah, it's a good question. If it says round it to the nearest tenth, don't round everything in the whole problem to the nearest tenth, because it will definitely be off by a little bit. Test corrections are posted, and they're due on Monday, as always. Any questions about the test? Okay, so today we're going to start the next unit. We have 2 more short little units left, and then we're going to have a final exam. Okay, so this unit has to do with volume of 3D figures. The last unit was all about surface area, so this is about volume. So today we're going to talk about volume of prisms. So remember, a prism is just a 3D figure that has congruent and parallel bases, top and bottom, and then every cross section that's parallel to the base is also congruent to the base. That's what a prism is. That's the definition of prism. You can have right prisms or non-right prisms, right? So let's start with a rectangular prism. For a rectangular prism, rectangular prism. Which is just like a box shape. Box shape like this. There's 3 relevant dimensions. There's length, width, and height. Everybody knows this. What's the volume formula for a box? Length times width times height, right? So the volume is equal to length times width times height. Okay, so it's possible they might give you all 3 of those things, and you just have to calculate the volume. That's super easy. So if they said, for example, the box, the length equals 8 inches, the width equals 1.5 feet, and the height equals 6 inches. So the first thing you'd have to do is just realize that the units aren't the same. So you got to change the units so that they're all the same. You can either change the 8 inches and 6 inches into feet, or you can change the feet into inches. That seems easier to me, because it's only one thing to do instead of 2 things. So that's the first thing I would do. I would change this. How many inches would that be? That's 1.5 feet. Yeah, 18. You just multiply 1.5 times 12. You get 18 inches. So the volume is equal to 8 times 18 times 6. So using the calculator, 8 times 18 times 6 is 864. And what would be the units in this case? Yeah, inches cubed. When you're talking about volume, the units are always cubed. Cubic inches, cubic feet, cubic yards, whatever. So this is inches cubed. So let's make a note about that. Note. For volume, units always cubed. Okay. Another thing they might do is instead of giving you length, width, and height, they might give you 2 out of 3, and they might give you the volume and say, find the missing one. So for example, they might say something like, for a box, the width equals 7 centimeters. The height equals 2.5 centimeters. And volume equals 103 cubic centimeters. Find the length. So that's no big deal. You're just going to solve a different equation, an equation in which the variable's in a different spot. So this equation would be length times width times height equals volume. So this is length times 7 times 2.5 equals 103. So if I multiply 7 times 2.5, 7 times 2.5, I get 17.5 equals 103, and then just divide by 17.5. So the length would be 103 divided by 17.5. Okay, so 103 divided by 17.5 is this number. So say you want it to the nearest tenth. This would be 5.9. Thank you. 0.9 millimeters. Okay. Any questions so far? Super easy. All right, so the next thing then is what if it's not a rectangular prism, but some other type of prism? So for any prism, the volume is equal to B times H. And in this formula, the B is the area of the base. This is the area of the base. And if you think about the rectangular prism volume formula, it follows this formula as well, right? Because length times width is actually the area of the base. If you take length times width, that's the area of the base, times the height, that's the same thing that we're doing here, okay? So if they gave you a picture, suppose they gave you a triangular prism, okay? See that triangular and let's draw it on its side. Like triangular prism. And let's say the triangular base is actually a right triangle. And let's say this is 4 and 12 and 14. And let's say the units are the sculpture. Or it's a really big piece of cheese. 100 like cheese. So all you're gonna do is you're just gonna take the area of the base times the height. So the base in this case is this triangular piece. Okay, so don't be misled by the word base. It doesn't necessarily mean bottom. Depends on how the thing's sitting, right? How do I know that that's a base? Without me telling you. What's that? Well, you got to think about what the definition of prism is. What are the bases? How can you tell a base based on the definition?
Because it says triangular.
It says triangular prism. That's a good point. Yeah, the word triangular, that refers to a description of the base. So that's one thing. Another thing is the bases of a prism are the two sides that are parallel to each other and congruent. And in this case, it has to be the two triangles. If you look at any other two faces of this prism, they're not parallel to each other, right? So the triangles are the ones that are parallel to each other, therefore they are the bases. If I know that this is a prism, and that's all I knew, if I just said, here's a prism, you would know that it has to be a triangular prism, and the triangles are the bases because those are the two sides that are parallel to each other. Everybody cool with that? Okay. So, in this case, the volume would be B times H. B part is the area of that triangle on the end. It would be 1/2 4 times 12. That's the B part. The H part is the 14. Okay, so half of 4 times 12, that's half of 48 is 24. So the volume would be 24 times 14. 24 times 14 is 336 cubic feet. Feet cubed. Okay. If you had a different shaped prism, who can predict the next example that I'm going to do? Don't be afraid.
Something that ends with John.
No?
You do a hexagon?
Yeah, exactly. I'm going to do a hexagon, right? Because I've done a hexagon for every single thing we've done. Why do I choose hexagons all the time? Yeah, because the little triangles that you can split a hexagon up into are special in what way? They're equilateral. Okay, so I'm going to...
It was definitely.
Well, the word gone was in it.
Yeah, it could have been.
That's true. That's true. You basically said that you're going to give an example, and you weren't wrong.
Yeah.
I am giving you an example. So here's a regular hexagonal prism. I'm down with whatever makes you feel good about yourself and more confident mathematically. Regular hexagonal prism. So remember what that looks like? It's like a big fat pencil. It's a regular hexagonal prism. And suppose we had some measurements like, let's say the length of a side of the hexagon is 8 millimeters. And let's say the height of the prism is 12 millimeters. Why do you think I always pick the length of the side of a hexagon to be an even number? I'm asking you guys to really predict my thinking. Yeah, go ahead. It's easier to, yeah, it's easier to cut in half because that's what you have to do when you're talking about the height of the little triangle is you have to split the triangle in half, right? Like if this is one of these equilateral triangles. Now, it doesn't quite look equilateral because it's 3D and I'm looking at it from its side. But if I'm trying to find the height of this, remember, this is split up into two pieces, 4 and 4. And what's the height of that triangle? 4 radical 3. Good job. This is 4 radical 3. If I had picked this to be 7 millimeters, this probably would just be messier, because then it would be 3.5 and 3.5, and this would be 3.5 radical 3, which is a little weird. So I'm trying to make the problem a little bit more friendly by making this even, okay? So now we can do it. We can say the volume is the area of the base times the height. The area of the base, that's the area of that hexagon. It's really just the area of this red triangle times 6, right? So it's 1/2 8 times 4 radical 3 times 6. That whole thing there is the B part. Any questions on that? Times the height of this prism, which is 12. So this question, they would probably say, leave your answer in simplest radical form, because that's easy to do. I'm just going to multiply all the numbers that are outside the radical together. So if you think about all the numbers that are outside the radical here, we got 1/2 of 8, which is 4, times 4, times 6, times 12, right? Those are all the numbers that are outside the radical. 4 times 4 times 6 times 12. 1152. That's all of these numbers outside the radical. 1152. And then inside the radical, just radical 3. That's the answer in simplest radical form. 1152 radical 3 square millimeters. Cube. Yeah, thanks. I would say that I did that on purpose to see who would catch it, but I didn't. Any questions? So even if I had a weird shaped prism, hang on, I got this weird shaped prism. I'll show it off. Do this thing. This is called a Franken-cube. It's a Rubik's Cube that I made myself by taking other Rubik's Cubes and cutting them up and gluing them together. Isn't this weird?
Can you solve it?
Yeah, it's solvable. It's solved now. But yeah, you can mess it up and solve it. Yeah. But anyway, it's a prism, right? Because it has a parallel base here, and a parallel base here. They're congruent to each other, and if you take any cross section, it's congruent to that as well, right? So if you just think about this prism, this formula should make perfect sense. Like if I count the area of the base just by thinking of each of these little squares as being a square unit, I have 9 plus 8. So there's 17 square units in that yellow face, right? So if there's 17 square units in this yellow face, you can just think it's like there's 3 layers of it. So there's 17 cubic or cubic units in the bottom layer, and then 17 in the middle layer, and then 17 in the top layer. So the total volume is 51. 17 times 3. That kind of makes sense? Just wanted to show this off. All right, so that's it. The homework is in Delta Math, and it's just called volume of prisms. That's all there is to it. I'm going to stop recording here. Oh, one more thing. Yeah. One more thing. There's no lesson tomorrow, and there's also no quiz. It's just a free day, just like normal Wednesdays. Okay?
I feel like I should be. We barely even touched chapter 21. I really focus on that. We barely filled in chapter 18, 19.
That's how it all started, man. I
At
know,
least
but
60.
yellow pen literally spells
I'm
our
not
name.
gonna take that.